challenges that we're going to run into is deciding who goes in the center, okay? And you're kind of like, okay, but none of these have a center, so what are you even talking about? So depending on which page you have, everybody should have this somewhere on the right-hand side of your page, if you just kind of look. Okay, so in the examples, we have a C, an H, and an I. Do you guys see that? Yes. Who goes in the center? Exactly. Yeah, so exactly. You shouldn't be able to answer that. So let's go over these rules real quick. All right. So who goes in the center when I have something that looks like that? All right. So often it's the unique atom. What I mean by unique is it is where you only have one type of that atom. Does that work for this one? No. C, H, and I, right? And we have only one C and one I. That doesn't work. All right. So the next thing you would look at. Often the least electronegative element, okay? Which you're like, okay, so that is ice cream cone trend. So we're looking for the tip of the ice cream cone. But once again, carbon is like up here, iodine is right here. That's not an easy one either, right? So number 2 didn't work for us. Number 3, if carbon is present, it will be central. Put a star next to that one because you can always guarantee that one. Carbon is our friendly element. If you think about it, when we were doing the rolling the dice lab, a lot of you struggled when you got carbon because you're like, well, how do I know whether to put it as positive or negative, right? Because it's plus or minus 4 was its oxidation number. It's right in the middle. So carbon bonds with everybody. That's why it's part of our biomolecules. A lot of those different things that you might have learned in biology year. Carbon is everywhere, all right? So carbon and silicon with the plus minus 4 idea, they will have different types of bonds and they will bond with everyone. All right, so that's a good one to rely on. Hydrogen will never go in the center. Never, never, never. Okay, so have you figured out who's going to go in the center on that one example yet? Carbon, yeah, good. All right, so hydrogen will never be central. Okay, reason why. How many dots does hydrogen have? How many electrons does he have? 1. He has 1. All right, so basically hydrogen can bond, and can it do anything else? No, because that's the most it'll ever be able to take on because it only has 1 available to bond anyway. So it bonds and then it's done. So hydrogens always get sprinkled on the outside of your molecules, okay? All right. You're going to always check for your octet rules. Okay, including the exceptions. So hydrogen is one of the exceptions. So make sure the element has the right number of valence electrons. Some of you guys, by the way, are up here. I think most of you should be writing up here. Okay, all right. This is where I'm not going to match up completely. All right, the word is still the same. So all should have how many? What's the octet rule? 8. Good. So all should have 8 electrons, but we have these exceptions. So I'm just going to write my exceptions a little bit bigger. I recommend you make them large enough for you to see. Hydrogen will only go up to 2. Beryllium will only go up to 4. Boron and aluminum will only go up to 6. Those are the exceptions you do need to be ready to use. Now, does it bother anyone that we included beryllium, aluminum, and possibly boron? If it doesn't, then what's wrong with you? No, I'm just kidding. No, but it should bother you a little bit because you're like, okay, that's a metal. That's on the metal side. It's an alkali earth metal, right? And you're just kind of like, how is this? I know. That whole row gets a little complicated. It's a little beyond our scope, so I'm not going to be explaining it right now. Okay? But you'll see it in both of the types of drawings and representations, okay? So just be aware that these will show up, so be ready to put them into your Lewis structure. Just depends what we're asking for, all right? All right, so those are the max numbers that they can go to. So just to make sure we got what we needed. In NH3, who's going to be in the center? Nitrogen, good. So go ahead and put nitrogen. And the reason why is because it is unique. It's unique and no hydrogen. Both of those reasons tell us that nitrogen will go in the center. Okay? So I think I did the same thing with third period as well. So tomorrow I will go over this N minus A equals S. Actually, no, it's 4. We're good. Let's keep going. Just a little bit longer. I promise. Just a little bit longer. All right. So look at the next part. So if I just gave you a paper today, then you have these steps already written. So that's good for you. Just follow along. Everyone else, we're going to be writing in what we would have to do for this NAS thing. Okay, so you guys all have on your paper, it says N minus A equals S. Do you guys see that? Yeah. Okay, perfect. So what you're going to put for that. Okay, so I'm just going to write it down here. So after you picked your central atom, okay, so central atom first. Then you're going to figure out how much is needed. Meaning octet roles. Okay, so we're going to pay attention to how much does each one of them need, and you're going to add them all together. Then you're going to figure out available, which means you are looking at your valence electrons for each element. And you're going to add those together. You're going to take the sum of needed minus the sum of available. Okay? So you're going to subtract these two, and you will come up with your shared number. So these are going to be shared electrons, which you'll then divide it by 2. Which will get you the number of lines. So if you got the page that had that on there, you probably want to add the divided by 2. Because we know that once we have that number, we want to know how many lines, you want to know how many are shared, right? So what I mean by all of this, because that's a lot of stuff right there, right? Let's look at the example that I gave you, which was the CH3I. Okay, so the CH3I. So for needed, just go ahead and write your stuff out for this. So needed. So we have carbon, we have hydrogen, another hydrogen, and an iodine, right? That's what is made up here. All right, so needed. Carbon. What is an octet for carbon? What's the number?
8.
8. Good. So we're going to say 8 plus, what is it for hydrogen? 2 plus another 2 plus another 2, right? These are all the neededs. So what does it need to be? What are they trying to do? And then finally, iodine. What's iodine's octet? 8 again. So when you add those together, what do we get? 8 plus 2 is 10, plus 2 plus 2, 14, plus 8, 22? 22. All right, so go ahead and write that number down. Just follow along for now. I know it's a lot. All right, A. A is going to be your available. That means your valence electrons. What's the valence electrons for carbon?
6.
Nope. He's in group 14. 4. How many does hydrogen have? 1. Could you put 1 times 3? Yes. All right, so 1 plus 1 plus 1. And then how many does iodine have? 7. Good. So when we add those together, we get 4 plus 1, that's 5. Plus 1, 6. Plus 1, 7. Plus 7. 14. All right, what is 22 minus 14?
8.
It's going to be 8. All right, so we're going to divide that by 2 because of 2 electrons for every single bond. How many bonds are we going to have? 4. So what that just told you was that we already know we're going to put carbon in the center. Okay? So I'm just going to use this space. I know that we have another example. We'll put it at the bottom. I'm going to put carbon in the center. Okay? I'm going to go ahead and put 4 lines around it because this told me I have 4 lines. I'm going to put the other elements around it. 1, 2, 3, and then iodine. Does it matter which way you go? No, absolutely not. Okay, so now what we have 1, 2, 3, 4, 5, 6, 7, 8 electrons on my page. We have to have 14. Where do you think those lone pairs are going to go?
Iodine.
Why?
Because it has extra electrons. It's the first one that needs electrons.
Yeah. You both, I think you're saying the right thing. You're absolutely correct. Yes and yes. All right. Because can hydrogen take on any other electrons? No. All right. Does iodine already, usually when you just draw it by itself, already have a bunch of lone pairs on it? Yeah, that's where it comes from. All right. So yes, we're going to put those extra 1, 2, 3, 4, 5, 6. So now we have 2, 4, 6, 8, 10, 12, 14. We're good. That's your answer. Okay. Now, the nice thing about this, because you're kind of looking at that and you're like, well, why didn't we just connect dots? I agree. We'll probably do that the most. But what this is going to actually help you with is on tomorrow's, we're going to do this one. If you use the needed, available, shared, you find out you have a double or a triple bond somewhere. So we'll do that tomorrow. All right? Great job today.